Hello, Algebra 1 CP students. Hopefully, you're having a great morning so far. Today, what I would like to do is start introducing the concept of parallel and perpendicular lines to you. But before we do, please see if you can write the equation of a line in y equals mx plus b form given the following information. First problem here, a line that passes through the point -4, 5 and has a slope of -1/2. Second problem here, a line that passes through the points -2, -7 and 1, -1. This should be a great review of what we did a couple classes ago. Try your best. Pause the video, take maybe about 5 minutes, and then pick it back up. I'll see you then. Hopefully by now you had an opportunity to pause the video, try these problems on your own, and see if you can get the answers. We'll go through them now. If you didn't, now's your last chance, but we're going to go through them now, all right? Remember that for both of these, your goal is that you want to write the equation of a line in the form of y equals mx plus b, where m is your slope and b is your y-intercept, right? Well, a great starting spot for us would be to say, ooh, I'm given the slope right away. The slope is -1/2. Let's just take that and put it in for m to say, well, our slope right there is -1/2. So we could start with our equation of the line being y equals -1/2 x plus b. I still don't know what that b value is, but I can find it. And the way that I can find it is by using the coordinates that is given to me. I know that this gives me a value for x and a value for y that this line would pass through. And we have an x and a y in our formula, or it's not our formula, our equation as well. So I could say, well, let's plug in -4 for x, let's plug in 5 for y, and solve for what b is. That would tell me that 5 is equal to -1/2 times 4, times -4 plus b, right? Y is 5, x is -4. Here we do have a situation where we're multiplying by a fraction, but hopefully this isn't a panic-inducing moment for you. I would see a negative times a negative is going to be a positive, and half of 4, well, half of 4 is just 2. All right? If you ever need to use a calculator for something like that, you certainly can, but I do want to encourage you to just think about it logically and say negative times negative is positive, half of 4 is 2. Done. Right? Cool. Again, if you do need a calculator, though, you can use one. Next, to get b by itself, the last thing we'd have to do is just subtract 2 from both sides. We get that 3 is equal to b. And since we know that our y-intercept, our b value, is equal to 3, we can go back up to our equation up here and just say, well, our equation of the line would therefore be y equals -1/2 x plus 3. Just like that. All right? Hopefully that made sense. One little twist that we can throw at a problem like that is exactly like number 2 here. Instead of giving you the slope outright, instead I'm just giving you 2 points. But we can find the slope, so you're missing that great starting spot of the slope, but you can find it. We did finding the slope of a line that passes through 2 points. We can say that the slope, remember, is the change in y over change in x. Vertical change over horizontal change, it's your y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And if I identify my information, this is my first x coordinate, this is my first y coordinate, that's x sub 1, y sub 1. This is my second x coordinate, this is my second y coordinate, that's x sub 2, y sub 2. We could then say that the slope of the line is equal to y sub 2, -1, minus y sub 1, so minus -7, over x sub 2, 1, minus x sub 1, minus -2. Notice how I'm being very careful with my negatives in parentheses. Let's see what we get. -1 minus -7 is going to be -1 plus 7, which is 6, over 1 minus -2 is the same as 1 plus 2, which is 3, and 6 divided by 3 is +2. All right? So just like over here, we could now start by plugging our slope in for our equation and say y equals 2x plus b. I still don't know what my b is, but notice we're pretty much now in the exact same situation that we were in before, where I have my slope inserted into my equation. I have a b value that I don't know, but I do have points that are given to me that I can use. All right? One point that I want to make about the slope, by the way, excuse me, is that if you actually called this point instead x2 and y2, and say you called this one x1 and y1, that's totally fine if you said that this is my first point, this is my second point. You'll actually get the same slope. You would get -6 divided by -3, which is +2 anyway. So that's totally fine. What you can't do is you can't mix match them. You can't crisscross, and you can't say, oh, this is my x1, this is my y2. That doesn't make any sense, right? You have to pair x1 and y1 and x sub 2 and y sub 2. All right, just wanted to make that point in case you happen to call this x sub 1 and y sub 1. Now, going forward from there, again, we have these points we can plug in for x and y. It doesn't matter which one you pick. Personally, I would gravitate towards this point because I would see, ooh, these are probably easier numbers to work with. So if I plug in 1 for x and -1 for y, that gives us -1 equals 2 times 1 plus b. You could use this one if you want to. Nothing wrong with it. You'll get the same answer. 2 times 1 is 2, so that gives us -1 equals 2 plus b. And subtracting 2 from both sides would give us that -3 is equal to b. So going back to our equation for y equals mx plus b, we could now write this as y equals 2x minus 3, since my y-intercept is -3. Okie dokie. Hopefully that makes sense as to how those were done. Should be a nice recap of what we've talked about so far. And now, given that information, let's go into what the actual subject of the video is on, which is parallel and perpendicular lines. Ready for it? Let's do it. Now, parallel and perpendicular are maybe words that you've heard before, right? Unlike other math words that usually don't make their way out of the classroom, parallel and perpendicular are words that are used pretty frequently in English. So what does it mean if two things are parallel? Well, if two lines are parallel, that means that they will never intersect. They're going in the same direction, so to speak. I'm just going to do a rough example here with some pens on the paper, but these two lines, if I imagine that these pens were lines, are parallel, because if you notice, they have the same slope and would just be traveling forever and ever and ever and ever and never intersect with each other, right? It's kind of a sad existence. They don't know that each other exists, yet they're living the same lives. Anyway, if my lines have different slopes, though, like say my pens were oriented this way, they would not be parallel, because if I kept going, they would eventually intersect, not parallel. So in order for our lines to be going in the same direction, so to speak, being sort of angled the same, have the same steepness to them, what needs to be the same about them to make that happen? Well, it's the slope. The slope of this line and the slope of this line need to be exactly the same to ensure that they never hit each other, because they just need to keep traveling in that same direction, sort of keep going together in the same direction. That's what makes them parallel. All right. So I could say here, to write down all of that, I will say that two lines are parallel if they never intersect. Okay? Two lines are parallel if they never intersect. And in order for our lines to never intersect, that would mean that parallel lines have the same slope. All right. That would mean that the slopes of parallel lines have to be the same. So let's take a look at our first example we came up with from the do now. From the do now, the first example was y equals -1/2 x plus 3. A slope of -1/2 and a y-intercept of 3. If I wanted to write the equation of a line that was parallel to that, right? What if I wanted to find something that was parallel to that? Well, we know that our parallel lines have to have the same slope. So my m, my slope, has to remain unchanged. Y equals negative 1/2 x. My y-intercept, though, does have to be different. But it could be whatever you want it to be, right? Suppose, again, this sort of crude example with my pen is my line of negative 1/2 x plus 3. It would actually be that way. Well, if I made my y-intercept bigger than plus 3, then it's just going to sort of shift it upwards like this. But it's still going to have the same slope, so it's still going to be parallel. If I made it smaller than plus 3, well, now it's going to be down here, but again, still parallel, still going in the same direction. So we could say an example of a parallel line, y equals negative 1/2 x plus 7, for example. That is parallel to y equals negative 1/2 x plus 3. They have the same slopes, but different y-intercepts. So they're just, one is above the other one, but they're both traveling together. They're never going to meet each other. Another example of a line that's parallel to that, and parallel to both of them actually, is we could say is y equals negative 1/2 x, I don't know, minus 5. That's also parallel to both of those because it's just going to continue with that same slope going in the same direction, just like this. All right. Or if you want to get really crazy, how about y equals negative 1/2 x plus 1,000? Certainly I would not draw that on a graph, but you could picture that that still is parallel. It has the same slope. It's going to be traveling in that same direction at that same angle, that same steepness, and it's just going to be shifted way up here, but still going to be parallel. They're never going to cross each other because they have the same slope. All right. If I look at my other example from the do now, the other one was y equals 2x minus 3. Lines that are parallel to those. Well, again, the slope just has to stay the same. The y-intercept can change, but the slope has to stay the same. So how about y equals 2x minus 6, right? As long as that slope is still equal to 2, then your y-intercept changes and you have a parallel line because they would both be sloped the same way. All right, and I'll show you the connection on the graph tomorrow, but they'd both be sloped the same way. Also, we could write instead, how about y equals 2x plus 1? That's parallel as well. It would have the same slope. It would be positioned above this one, but it would still be continuing in that same direction. They'd be continuing together forever and ever and ever, never to intersect. All right? And do keep in mind that parallel lines do have to have the same exact slope, so that can't change. But the y-intercept doesn't have to be dramatically different. We could say that y equals 2x, let's say even minus 3.1, right? Only very slightly off from my y equals 2x minus 3. They would be a slight distance apart, but still parallel because those slopes are the same. So again, parallel lines, same slope, different y-intercepts. All right, but that y-intercept could be whatever you want it to be, as long as it's not the same, because then it would overlap, and that would be like the opposite of parallel. So just keep that in mind. All right, that's parallel. That's how you write the equations of things that are parallel to other lines. Let's talk about now perpendicular is the other one. All right, let's talk about perpendicular. We'd be able to say that two lines are perpendicular if they intersect at a 90-degree angle, also known as a right angle. You may have heard that before too. All right. So two lines are perpendicular if they intersect at a 90-degree angle. In other words, they make that perfect X of an intersection, right? They're not like sloped steeply like this or flat like this. They meet perfectly to form that perfect 90-degree corner. All right. A great example I always like to give is, look next to you. You probably have a wall and a floor in some immediate vicinity of you. If you were to draw a line on the wall going straight down to the floor, don't actually do it, or don't get me in trouble, or draw a line on the floor going to the wall. Well, those two lines would meet at a corner, correct? The line on the floor would meet the line on the wall at this perfect 90-degree corner. All right, and that's what we call perpendicular. For two lines to be perpendicular, this one's a little harder to figure out, so I'll tell you for the sake of time that perpendicular lines have opposite reciprocal slopes. All right. So the slopes of perpendicular lines are opposite reciprocals of each other. What does that mean? Well, opposite means that if you had a positive slope, well, change it to negative. Or if you had negative, switch it over to positive. Switch that sign. And the reciprocal, I'm pretty sure you've heard that word before in middle school, means that you're going to be taking your fraction of a slope and swapping the numerator and denominator. Flip-flop that fraction. The reciprocal of a over b for any two values a and b is b over a if you take the reciprocal. All right? So just to hit you with a quick example, suppose that my slope was, I don't know, I'll just make one up, 3/4, right? And I wanted to find the opposite reciprocal of that. If I wanted to find the opposite reciprocal of 3/4, well, the opposite means it's a positive, so we're going to switch it over to a negative. And the reciprocal, the 4 in the denominator, is now going to swap to the numerator. The 3 in the numerator is going to swap to the denominator. It's going to be -4/3. Okay, that would be your opposite reciprocal of 3/4. Hopefully that makes sense. So let's take a look at our examples again and see if we can come up with lines that are perpendicular. I would say if I had my first example again was y equals -1/2 x plus 3, a line that is perpendicular to that again, we would need to find that opposite reciprocal slope in order to make that happen. So my slope here is -1/2. What is the opposite reciprocal of -1/2? Well, opposite means we're going to change that negative into a positive. Reciprocal means that 1 over 2 is going to flip-flop to 2 over 1. So it would be positive 2 over 1, and 2 divided by 1 is just 2. So that means the slope would be 2, y equals 2x. But what about the y-intercept? Well, the y-intercept can really be whatever you want it to be. It can be the same, plus 3 if you want to leave it the same, or it can be something else. If the only instructions are to just write a line that's perpendicular to this, you can make that y-intercept whatever you want it to be. All right? So I always say to myself, like, why make it harder than it has to be? Why not just keep it the same to know that, oh, the slope is the only thing that changes here, the y-intercept's the only thing that changes here, and those stay the same. That's totally fine. All right? We will be doing examples in a little bit, though, that have you find, in particular, what's the y-intercept. In particular, what's the y-intercept. But for now, if the only instructions were to write a line that's perpendicular to this, all you have to do is change that slope and the y-intercept if you want to, but you don't have to. All right? Let's look at our second example as well. Our second example of y equals 2x minus 3. Notice again to find a line that's perpendicular to that. I would have to say, well, I need the opposite reciprocal of 2, but that looks a little familiar, doesn't it? We got our slope of 2 over here. We said the opposite reciprocal of -1/2 was 2. Well, these go in reverse as well. The opposite reciprocal of -1/2 is 2, and the opposite reciprocal of 2 is -1/2. So you can go in both directions with that as well. We'd say that our opposite reciprocal, negative 1/2 x, and we'll say minus 3. All right? And or you could make it, you could change the y-intercept if you wanted up here. We could say this was y equals 2x plus 5. That's also perpendicular to this. We could say this is y equals negative 1/2 x, I don't know, minus 10. That's also perpendicular to this. As long as that slope is the opposite reciprocal, then we're in good shape. All right? Any questions, comments, or concerns about that, please feel free to let me know. But just as a quick little recap today, we went through some great do now problems on how to find the equation of lines given information. We also talked about what it means for lines to be parallel and what it means for lines to be perpendicular, just in general. To find lines that are parallel, they'd have the same slope. To find lines that are perpendicular, they have opposite reciprocal slopes. Tomorrow, we're going to look at the connection that these have to graphs, as well as do a couple problems maybe, if we have time, where we can say, what if we have to pass through a specific point? Or what if we have to have a particular y-intercept instead of just making one up? That's what we'll get to tomorrow. All right, if we have time. If not, we'll at least do the graphing stuff, which will be great. Anyway, regardless, I do hope you have a fantastic rest of your day, and I will see you then. All right, take care, and great job on parallel perpendicular stuff today.